All right, let's look at the review for your test. We're going to start with the self-test section here. This is number 1. So it says we're going to convert 7/9 of a revolution to radians. And so remember that 1 revolution is 360 degrees or 2 pi radians. And so for this one, I would just take 7/9 times 2 pi. And there's nothing I can reduce between the 2 and the 9. So then when I do that, I would just get 14 pi over 9 and just double check. There's nothing to reduce there. So that would be my answer, just 14 pi over 9. Number 2, how many degrees is equivalent to negative 5 pi over 2 radians? Remember, there's so basically they're just converting. We want to convert this from radians to degrees. So we're going to have negative 5 pi over 2 times, to convert that to degrees, we're going to multiply by 180 over pi. Just if you have a hard time remembering which one's which, remember if we already have pi in the numerator, to get rid of pi, we'd have to have a pi in the denominator. So it's going to be 180 over pi that we multiply by. And then I want to reduce this. And so the pi's cancel out. 2 I see goes into 180 90 times. So now if I take negative 5 times 90, I get negative 450 degrees. So that would be my answer for number 2. All right, number 3. So for number 3, we want to convert 120 degrees to radians. So if I'm going to convert to radians, I'm going to multiply by pi over 180. So I just like to go ahead and write that as a giant fraction and then just reduce it. So I see that 10 goes into both of those, so that reduces to 12 pi over 18, but I want to reduce that completely. I see that 6 goes into both of those, so that would reduce to 2 pi over 3. That can't reduce any further. We want to leave it in terms of pi, so that would be our answer, 2 pi over 3. All right, number 4 we didn't have to worry about. The reason why is because this year I don't want you just to plug things in your calculator. You do need to be familiar with the unit circle, but you're going to have to know how to do that. And I can't assess you on that this year, not specifically like that. So we'll skip that one, but let's look at number 5. So for number 5, it says, what is the tangent of 60? Well, remember, the tangent is equivalent to the sine divided by the cosine. And the sine of 60 degrees would be square root of 3 over 2. The cosine of 60 degrees would be 1/2. Now I want to make sure that we simplify this or reduce this. So I'm going to multiply the top and bottom by the reciprocal of the denominator, which is 2 over 1. And then we end up square root of 3, or the 2's cancel out, leaving us with just square root of 3. So the tangent of 60 degrees would just be the square root of 3. All right, for number 8, it says, for what values of theta from 0 to 2 pi are cosine and tangent both positive? Okay, let's think about this logically. Okay, so I'm just going to draw my axes here. So remember, so 0 to 2 pi is referring to 1 complete revolution around the unit circle. And over here in quadrant 1, this is where everything is positive. So this is where cosine will be positive, sine will be positive. Over here, this is where x is negative and y is positive. So this is where the cosine of the values will be negative and the sine of the values will be positive. Over here, everything is negative in quadrant 3. So the cosine and sine would both be negative. Over here, this is where the cosine would be positive, but the y would be negative. Okay, so it says, for what values are cosine and tangent both positive? Well, the cosine is positive here and here. And the tangent, remember, is sine divided by the cosine. So the tangent is positive here and here, because positive divided by positive and a negative divided by negative would both result in positive answers. So the only one where they both are positive is in quadrant 1. So that would be between 0 and 90 degrees, but it's talking about, it's in terms of radians, so we would say between 0 and pi over 2. So that's how you could say that theta, the values of theta would be between 0 and pi over 2. For what values in the same range, so again between 0 and 2 pi, are they both negative? Okay, so we're trying to figure out where would the cosine and the tangent both be negative. Well, the cosine is negative here and here, and the tangent would be negative when one is positive and one is negative. So this is when tangent is negative, and this is when tangent is negative. So the only place where they're both negative is in quadrant 2. So that's from pi over 2 to pi, whoops, erase, there we go. So between pi over 2 and pi is where both tangent and the cosine functions would both be negative. All right, number 9. It says consider the unit circle below. We're going to find the sine of theta. So theta is referring to this rotation. Where would that point be after? So the sine of theta would be the y value for that coordinate, for this coordinate right here. And we're given this information. Well, if that's our coordinate there in quadrant 1, down here, this would be the coordinate negative 0.156 and negative 0.988. So the sine of theta would be negative 0.988 because it would be the y value at that coordinate. So that's theta. So theta is right here. So this is theta. So when it says find the cosine of theta plus pi, well, that's referring to your half-turn theorem. And so we'd be going from this location and rotating it half a turn. Well, that brings us back to this coordinate that they gave us originally. So the cosine of that would be the 0.156. All right, so here it says give an exact value of the cosine of the opposite of theta if the sine of theta is 5/13. Okay, so this is using that opposites theorem. So the opposites theorem says the cosine of the opposite of theta is equal to the cosine of theta. Well, they give us this, so they give us the sine of theta, so we need to figure out, well, what's the cosine of theta? And it says exact value, so that means we don't want to use a fraction, or we don't want to use a decimal. We want to keep our answer as a fraction. So remember, if they give us the sine of theta, and we need to find the cosine, that's where we use the Pythagorean identity. So we're going to take cosine squared theta plus sine squared theta and set it equal to 1. So the cosine squared theta, that's what we're trying to find. And we know the sine is 5/13, so we'll square that and set it equal to 1. So I'm going to kill two birds with one stone here. I'm going to subtract that 5/13 squared from both sides. Well, 5 squared is 25, and 13 squared is 169. So now I just need to change this 1 to have a common denominator with the 169. So I'm going to change this to be 169 over 169. All right, so now we can subtract those values. So 169 minus 25 is going to be 144 over 169. Now so technically when I go and do the next step would be to take the square root of both sides. Oops, I don't know what's happening with my document here. But we would take the square root of both sides. Now when you take the square root of both sides, technically that means there's going to be two solutions, a positive and a negative. But they give us this restriction. This is telling us that our values are going to be between pi over 2 and pi. Well, pi over 2 and pi is over here in quadrant 2. And that's where the cosine, remember, is negative and the sine is positive. And we're trying to find the cosine here. Whoops. We're trying to find the cosine, and so the cosine is going to be negative. So when I go to get my answer here, all we're worried about, instead of worrying about both solutions, I'm only worried about the negative solution. And the square root of 144 would be 12, and the square root of 169 would be 13. So our answer for number 14 here would be negative 12/13. All right, so that was from the self-test section. Now let's move on to the review section. Okay, so again, we're having to do some more conversions here. Let's look at number 1. So we're going to do each of these consists of two problems. Part A, we're converting to degrees, and part B, we're going to convert to radians. Okay, so let's start with 1A here. So to convert that to degrees, now the key here is it's counterclockwise. Remember, when we're going Counterclockwise, that's when it's going to be positive. So I'm going to take 2/5 times a positive 360 degrees. Well, 360, we can reduce that because 360 is divisible by 5. That's going to be 72. And now I just take 72 times 2 and I get 144. So for 1A, that would be 144 degrees. For 1B, now we're going to convert that to radians. So now I'm going to take 2/5. One revolution around the circle would be 2 pi radians. Well, between the 2 and the 5, there's nothing to reduce there. So if I just simplify that, that'll just be 4 pi over 5. Okay, let's look at number 2. So starting with 2a, we need to convert that to degrees. So we're going to take 1/3 of 360 degrees. Well, hopefully you can see that 360 divided by 3 would be 120, and 120 times 1 would just be 120 degrees. So there's nothing more to do with that one. For 2b, we're going to multiply 1/3 times 2 pi. Oh, by the way, whoops, I made a mistake. Oh my goodness, I'm going too quick. Clockwise, if it's in a clockwise direction, remember that's where it's going to be a negative rotation. So this would be a negative 130, or negative 120 rather. And so for this one, this would be a negative 2 pi. And so your answer, again, nothing to reduce there, so we just have negative 2 pi over 3. That would be your answer for 2b. So you got to remember, don't make the mistake that I did. Don't forget, there it is. Don't forget when it's a clockwise rotation that your answer is going to be negative. All right, let's look at numbers 3 and 4. So for numbers 3 and 4, we're going to convert these to degrees without using a calculator. So that means we don't want to do this as a decimal. That's a fancy way of just saying we'll leave these as a fraction. Or actually, no, there's going to be degrees, so they should simplify without a fraction, hopefully. So we would multiply this by 180 over pi. Remember, we want that, so in that way the pi's cancel out. And I see that 6 goes in 180 evenly, so that's just 30. So now I could just take negative 5 times 30, and I get negative 150 degrees. So that would be my answer for number 3. For number 4, do that over here. For number 4, we're going to convert pi over 12 to radians. Or from radians to degrees. So this would be multiply that times 180 over pi. Again, the pi's cancel out. Now for this one, it says to convert to degrees without using a calculator. Just know that usually we would have these simplify nicely, where it's not going to be a decimal. And that's not going to happen here, actually, because 12 does go into 180. So let's see. 4 goes into here 3 times. 4 goes into 180 45 times. And now I see that 3 goes into 45 15 times. So that actually works out nicely. I was thinking maybe it would go as a decimal, but turns out it doesn't. It's going to be just 15 degrees there. All right, let's look at number 5. Numbers 5 and 6, for these two, what we're going to be doing is we're going to be converting these from degrees to radians. So the way I like to do that is just set it up as 225, because we multiply by pi over 180, so I'm just going to set it up as a fraction, and then we're just going to reduce that. Now, if ever you have a number that ends in 5 or 0, it's always divisible by 5. So if you're wondering how to reduce that, just recognize that they both end in 5 or 0, so 5 goes into those. And 225 divided by 5 would be 45. So we'd have 45 pi, and 180 divided by 5 is 36. Now that's not reduced completely, that's just reduced once. So now I see that, well, 9 goes into these, so 9 goes into 45 5 times, and 9 goes into 36 4 times. And that can't be reduced. So 225 degrees is the same as 5 pi over 4. So let's do the same thing with 330. So we're going to multiply that times pi over 180, so just write it like this. So when they end in 0, 10 is always goes into them. And I see that 3 would go into both of these numbers, so 3 goes into 33 11 times. And 3 goes into 18 6 times. 11 pi over 6 can't be reduced, so that would be your answer for number 6. All right. So for number 7 and 8, it's asking for how many revolutions are represented by a rotation of the given magnitude. So for number 7, remember that 2 pi represents 1 full rotation. Well, this is referring to, this one here, so the way this one's set up is we have 2 pi over 3, which is the same as, it's the same as 1/3 of 2 pi. Okay, so if 2 pi is a full rotation, 2 pi over 3 would be 1/3 of a revolution, or 1/3 of a rotation. So our answer would just be 1/3. Now, 630 is obviously more than one rotation around the circle. And so what we can do is we can say, well, this would be the same as 630 over, over 360. So we want to figure out how many rotations or how many revolutions around the circle this would be. So then we just reduce this. And I see that 10 goes into both of those. I see that 3 goes into both of these numbers. So 3 goes into 63 21 times. 3 goes into 36 12 times. And that's not fully reduced. 3 goes into both of those. 3 goes into 21 7 times. 3 goes into 12 4 times. So that's 7/4 of a revolution. Or if you said 1 3/4 of a revolution, that would be fine as well. So either one of those would be correct for number 8. Or I suppose if you said 1.75, you could also say 1.75. All right, let's skip to 23 here. So for 23, it says find the coordinates of P when theta is the following. So what you want to make sure that you understand is that to find the coordinates, it's always the sine of theta. I'm sorry, cosine of theta, sine of theta. It always goes in alphabetical order. So the cosine is your x, your sine is your y. An easy way to keep that straight is when we deal with the coordinate, they're already in alphabetical order, your x and your y. So the cosine and sine are going to go in the same alphabetical order. So it'll be cosine of theta, sine of theta. So we want to make sure for number 23 that your calculator is in radians. And there's actually a faster way to do this one, but I want to make sure that you know how to do this on your calculator. So if we're ever doing this on the calculator and we have something in terms of pi and we need to take the cosine or sine of that value, you want to make sure that your calculator is, like I said, in radian mode. So if I take the cosine of 5 pi, what's going to happen is you're going to get an answer of -1. So that means the x-coordinate would be -1. And if I did the sine of 5 pi, that would be 0. And if you think about it, this is what I was saying just a second ago. There's a much faster way that we could do this one. 5 pi would represent, well, 2 pi is all the way around the circle once. 4 pi is all the way around the circle twice. And then pi would bring us right there. Use a different color. So pi would bring us right there. So 5 pi is 2 times all the way around plus an additional pi, which would be halfway around the circle. And that's the coordinate -1, 0. All right, so now let's do 24. So for 24, it says it's going to be 2/5 of a revolution clockwise. Okay, so that means it's going to be in the negative direction. And so I need to figure out, well, how many degrees that would be. So I'm going to take 2/5 of -360. I could reduce the 5 goes into -360, -72 times. And if I multiply that times 2, I get -144 degrees. So 2/5 of a revolution clockwise is -144 degrees. Well, now I want to take the cosine of that and the sine of that. So when I do that on my calculator, so again, if I take the cosine of -144, I get about, if we round that to the nearest hundredth, it's -0.809. If we round that to the nearest thousandth, rather. Round that to the nearest thousandth, which, if this was a test question, I would ask you to do the same. That's kind of our typical place that we round when we're working with trigonometry. So then our sine of -144 would be -0.588. So that would be your answer for 24. All right, for 26, it says describe the domain and range of the cosine function. So remember, the domain would go from -infinity to infinity. And the range, and the range goes between -1 and 1. So that would be your domain and range for 26 for the cosine function. It just so happens that the cosine function and the sine function would both have the same domain and range. All right, so as you can see that in that last second there, that my Word document crashed. So, but here we go. Let's carry on with 27. So 27, it says, for what values of theta is tangent undefined? Now you want to remember that the tangent of theta is found by taking the sine of theta divided by the cosine of theta. And the one thing you can never divide by is you can never divide by 0. So we want to, anytime that the cosine is 0, it's going to be undefined. And so the cosine is 0 here at 90 degrees or pi over 2, and at 270 or 3 pi over 2. Now we want to describe this because we could describe this in terms of just one time around the unit circle or multiple times around the unit circle. So 90 and then 270, and then the next one would be, let's see, that'd be 450. So what they are going to be odd multiples of 90 degrees. Because 90 degrees, 90 times 3 would be 270, 90 times 5 would be 450, 90 times 7 would be 630. So we had each of those degree intervals is where it would be, the cosine would be 0. Or you could even say odd multiples of 90, or you could say odd multiples of pi over 2. It's the same thing. All right, 31. So 31, it says, for which value of theta is the sine of theta less than 0 and cosine of theta greater than 0? So in other words, where is, so this one's asking us, where is the cosine going to be greater than 0? So that's going to be where x is positive. And where the sine is less than 0, so that's where the sine is going to be negative. And that's going to happen over here in quadrant 4. Because quadrant 4 is where the cosine is positive and y is negative. So the way that we describe that is that's between 3 pi over 2 and 2 pi. So your answer would be D for number 31. All right, for numbers 34 and 37. This one, now this is going to be, on the test, it's going to be similar to this, but instead of k, I'd give you a number. And so you're going to have to know how to use, because I don't want you just typing things in your calculator and figuring out the answer. I want you to know how to apply these different theorems, these identities and different theorems to be able to find the values. Okay, so they tell us that sine of theta is equivalent to k. So let's figure out what the sine of pi over 2 divided by, or sine of pi over 2 minus theta would be. Well, that's going to be the complements theorem. And the complements theorem tells us that when we have the sine of pi over 2 minus theta, that it's equal to the cosine of theta. Well, hold on a second. I know the sine of theta, but I don't know the cosine of theta. Well, this one we're going to have to use that Pythagorean identity theorem to be able to find out what the cosine of theta is. Now, it's going to look ugly because we're working with the variable k. We're not actually working with the number, but just understand you need to know the process. So I'm going to do that over here on the far right, because this is going to be the one that requires the most work. So we're going to have the cosine squared theta plus, and I'm just going to put in the sine as k, so it's going to be k squared equals 1. Or we could write it like this, because I could subtract k squared from both sides and have 1 minus k squared. And now the key is, now before I do the last step here, it's saying that theta is between 0 and pi over 2. So it tells us that it's going to be in quadrant 1, so everything's going to be positive. So when I take the square root of both sides, again, technically, you'd have two solutions, a plus or minus square root of 1 minus k squared. But since all we care about is just the positive value, we're just going to say that the cosine of theta would be equal to the square root of 1 minus k squared. So that'll be your answer for 34. So 35. All these are in terms of pi. So when you're looking at your notes, or as you reflect on those, remember pi is 180 degrees. But this is referring to the cosine of pi minus theta. So that's going to be the supplements theorem. Well, that says, the supplements theorem says that the cosine of pi minus theta is equal to the opposite of the cosine of theta. Well, we just found the cosine of theta is the square root of 1 minus k squared. So it's going to be the opposite of that. So negative square root of 1 minus k squared would be your answer for 35. Now 36 is a tricky one, because 36, if you recognize, you don't have any that say theta minus pi. We have pi minus theta, so I'm going to change this to be the same as pi minus theta. But if I change that, because if I can't just switch the order, okay? So if I rewrite this, this is the same as negative pi plus theta, if I put the pi first. Well, I don't have anything that says that either, but I can, now this is where, again, I don't like this one. You're not going to have one that's tricky in your on your quiz, your test. But if I factor out a negative, now these are the same thing. Okay, so this is the same as sine of the opposite of pi minus theta. Because if I distribute the negative through, then I'd have negative pi plus theta, which is the same as the pi minus, or theta minus pi. All right, well, looking at our notes, we have a rule for this one because we know the supplements theorem says the sine of pi minus theta is equal to the sine of theta. But we have, we have that negative there. Oops. I have to highlight that. We have this negative here, so that means if the sine of pi minus theta is sine of theta, that means the sine of the opposite of that would be the opposite of the sine of theta. Okay, and it's only because of that negative there. All right, so we know the sine of theta is k, so our answer for this one would be negative k. So that would be your answer for 36. And lastly, 37 asks to find the cosine of pi plus theta. Well, this is a half-turn theorem, and so the cosine of pi plus theta is equivalent to the opposite of the cosine of theta. Well, again, we have the cosine of theta as the square root of 1 minus k squared, so this is going to be the opposite of the square root of 1 minus k squared. So that would be your answer for 37. All right, let's look at 58 through 61. So this, I really like these problems because these problems require us to make sure that we understand how the unit circle works, which for this year is the most important thing for right now. But let's look at how we find these out. So we are not, our answer is not, by the way, you didn't have to do B, remember, but our answer is not a coordinate. Our answer is a specific value, a specific letter from the coordinate, not just, like for example, the first one is not the coordinate AB. Okay, if I rotate a point from 1, 0, 20 degrees, that is going to bring me to that coordinate AB. But it's saying what's the sine of 20 degrees? The sine would be the y value. Remember, it's the cosine is your x, and the sine of theta is your y. So this would be equal to point B on the unit circle. So the next one, cosine of 520 degrees. Well, that's more than one full rotation around the circle. If I take 520 degrees and subtract 360, I get 160. So this is the same as the cosine of 160 degrees. Well, 90 degrees would be right here, and 180 degrees would be right here, so it's closer to 180 than it is 90. So it's either going to be E or F. And since we're dealing with the cosine, that's the x value, our answer would be E. That's an E for that one there. So number 49 would be E. All right, number 60. Now if you want to, for this one, if you have the unit circle memorized in radians, it makes it a little bit easier, or if you want to think about it in terms of radians, you could change this to degrees. But I like to look at this one as 8 pi over 9. Well, I know 9 pi over 9 would be really close to pi. Well, this is 8/9 of pi. So this is really close to pi. So it's got to be either E or F. And so since we're dealing with the cosine, we would say that that would be the letter E. And lastly, number 61, we have negative 28 pi over 9. Well, that's more than one full rotation. Okay, 9 goes into 28 3 times with a little bit over. So in other words, this negative 28 pi is really close to a little bit over, a little bit past 3 pi radians around the circle. Well, remember 2 pi represents 1 time. Now we're going, it's negative, so we're going clockwise. So this would represent 2 pi. So 3 pi would bring us right back here. But it's, like I said, it's a little bit beyond 3 pi because 9 goes into 28 3 times with a little bit left over. And so that means that the closest we would have is this coordinate EF. And again, since we're trying to find the sine value, that would be letter F. That would be the y value there. All right, for 63 to 65, we're using this diagram. And it says, so we're going to state the value. So just similar to the previous one, our answers are going to be using these letters here with A and negative B, or negative A, negative B. So it says, what's the sine of 180 minus theta? Well, that's using the supplements theorem. And the supplements theorem says the sine of 180 minus theta is equivalent to the sine of theta. Well, what's theta? Theta is right here. Okay, so theta is bringing us to that coordinate there, A, where the cosine of theta would be A, the sine of theta would be negative B. So the sine of theta would be negative B for that one, for 63. Now the tangent of the opposite of theta, well, that's the opposites theorem, which says that the tangent of the opposite theorem, or the tangent of opposite theta, is equal to the opposite of the tangent of theta. Well, what's a tangent of theta? The tangent would be the sine of theta over the cosine of theta. And the sine of theta we know is negative b, and the cosine of theta is a. So our answer for the tangent of theta would be the opposite of b over a. But remember, it's got to be the opposite of the tangent of theta. So since the tangent of theta is negative b over a, the opposite of that would be a positive b over a. And 65. So for this one, we're trying to find the cosine of pi over 2 minus theta. Well, this is a complements theorem. The complements theorem tells us that the cosine of pi over 2 minus theta is equal to the sine of theta. And what's the sine of theta? Well, again, if this is theta, sine of theta is the y value, which is the opposite of b. So for number 65, your answer would be negative b. All right, so let's look at 41. So this was, or I'm sorry, lesson 4.1. So these were 3 problems that I didn't like any of the problems that were in the review. So I went back to lesson 4.1 and I liked these problems better. And so this is dealing with that arc length formula. So remember, the arc length formula tells us that we're always going to take, so the arc length is the radius of the circle times the measure of the angle, and this has got to be in radians. Okay? Remember, an arc length is just part of a circle. Remember, the formula for a circle is 2 times pi times the radius, and 2 pi is 1 time around the circle. So that's the connection there between a little bit of geometry and trigonometry. All right, so use a circle to write if the measure of angle ABC, so ABC is this angle here, is 5 pi over 6 radians, and the radius is 33, compute the length of arc AC. We're trying to find out what this blue arc is here. Okay, so if that's the case, then we're just going to use that formula. So I'm just going to do 13 down here. So we're going to use the formula. The radius is 33 times the arc length. We already have that in radians. So it would be 5 pi over 6. Now it doesn't say to write your answer in as a fraction or as a decimal. But usually for these problems, they're usually story problems where we have like the length in centimeters or inches. So for this one, let's just go ahead and do this as a decimal. So even though if your answer, so the answer key says it's 55 pi over 2, if you reduce that, because 3 goes into here 2 times, and 3 goes into 33 11 times. So we would get 55 pi over 2 would be your answer if we left it as a fraction. But if we did this as a decimal, your answer would be 86.4 if we rounded it to the nearest tenth. So just know on the test for a question like this, have you round to the nearest tenth. All right, let's look at number 14, because this is one that's more of a story problem, where we have a measurement, again, that will round to the nearest tenth. So for the first one, 14, it says find the arc intercepted by an angle of 3 pi over 4. So again, this is already in radians, so it's really simple. The only thing you got to be careful of is the diameter is 8 centimeters. We want the radius. So for this one, the arc length, we would find our radius is 4 times the measure in radians is 3 pi over 4. Now technically the 4's would cancel out, leaving us with 3 pi. But if we did that as a decimal, we get approximately 9.4 centimeters. Because usually we don't refer to centimeters in terms of pi. So that's why I would go ahead and simplify it. All right, last problem, number 15. Find the length of an arc intercepted by an angle of 63 degrees. Okay, so we're going to use the same situation here. So again, if you didn't watch the question 14, they give us a diameter is 8 centimeters. So that means the radius is 4 centimeters. Okay, that's what we want to use here. And 63 degrees, we also want to make sure that our numbers are in terms of radians. So I need to convert 63 degrees to radians. So to convert that to radians, we'd multiply by pi over 180. And then I would just multiply all this together, and when you do that, we would get approximately 4.4 centimeters for that one. All right, so hopefully that answers all the questions that you had from the review. If you still have other questions, please make sure you ask. So you can do really well in this upcoming test.